What if I told you that a computer just solved in 4 minutes what would take the world's fastest supercomputer billions of years? This isn't science fiction, this is the future unfolding right now. Imagine a machine so powerful, so precise, that it could outpace every supercomputer on Earth, not just by a few seconds, but by billions of years. Welcome to the quantum revolution, and at the heart of it stands Jiuzhang, China's 76-qubit quantum computer that has just made history. In a world where classical computing is reaching its limits, Jiuzhang has leapt far ahead, unlocking possibilities previously thought unattainable. Developed by a team of brilliant physicists at the University of Science and Technology of China, this quantum computer achieved something extraordinary. It completed a complex calculation using Gaussian boson sampling in just 4 minutes, a problem so difficult that it would take the fastest classical supercomputer an estimated 2.5 billion years to solve. Let that sink in. 4 minutes versus billions of years. The tech behind Jiuzhang. Unlike conventional computers, Jiuzhang isn't built with chips, wires, or transistors. Instead, it's a marvel of photonics, built using lasers, mirrors, prisms, and photon detectors. It uses a technique known as Gaussian boson sampling, which involves measuring the output of quantum light particles, or photons, in complex networks. The randomness and interference patterns of these photons allow Jiuzhang to perform calculations with unimaginable precision and speed. In technical terms, Jiuzhang managed to manipulate and sample 76 photons. To put this into context, classical supercomputers struggle beyond 5 photons, anything above that creates a data explosion that's computationally unmanageable. Jiuzhang blew past that boundary, proving the world is on the cusp of true quantum supremacy. Why this matters for the future. Quantum computing is not just a flashy lab experiment. It's a new way of processing information, based on quantum superposition and entanglement, allowing multiple computations to occur simultaneously. Where classical bits are either 0 or 1, qubits can be both at once, exponentially increasing processing power. This means quantum computers like Jiuzhang could transform quantum chemistry by simulating molecular interactions for new drug discoveries, solve previously unsolvable mathematical problems in minutes, optimize logistics and financial models on an unprecedented scale, lay the foundation for a fully secure, quantum internet. And all of this is just the beginning. A leap that rivals the moon landing. Europe is at the forefront of quantum research, with institutions like CERN, Oxford University, and Delft University all investing heavily in quantum technologies. But what Jiuzhang has achieved marks a global milestone. It's a wake-up call for governments, researchers, and industries to accelerate investments in quantum readiness. This isn't just a scientific curiosity, it's a race for technological dominance, and the world is watching. How is Jiuzhang different from Google's Sycamore? You might remember Google's Sycamore, which achieved a similar quantum advantage in 2019 with superconducting qubits. Jiuzhang, however, uses photonic quantum computing, which is not only faster but also easier to scale and operate at room temperature, unlike Sycamore, which requires ultra-cold environments. Each has its strengths, but Jiuzhang's photonic approach could lead to more practical, scalable quantum computers in the near future. We're witnessing a turning point in human history, a paradigm shift where quantum mechanics meets real-world application. Jiuzhang has shown us a glimpse of what's coming, computers that think differently, that solve differently, that redefine the limits of possibility. But with great power comes great responsibility. The ethical, economic, and security implications of quantum computing are immense. Who controls this technology? How will it be used? Will Europe lead or follow? If you're passionate about the future of science and technology, like, share, and subscribe to stay ahead of the curve. Drop a comment below. Do you think quantum computers will change the world in the next 10 years? And don't forget to hit the bell icon so you never miss a breakthrough update. Let's explore the quantum future, together.